Our objective for this video is to be able to measure angles in radians and to convert between degrees and radians. Now, radian is a new way that we're going to measure angles. It's similar to like if you were measuring temperature, sometimes we use Fahrenheit and sometimes we use Celsius. When we're measuring, for instance, distance, sometimes we'll use feet and miles. Sometimes we'll use meters and kilometers. There are different ways of measuring the same thing, just different units. Well, in this case, what we're going to do is we've been measuring angles for most of what you've done. For instance, geometry, you've used degrees. Previous courses, you've used degrees. Now we're going to start using in mathematics from Algebra 2 on. You'll often use radians as the measurement of how you measure the different angles. Let's talk about what a radian is. If we look at a circle here, we've got a circle that this is our radius. If you take that length of a radius, this is how long the radius is, and if you were to lay it along the arc going counterclockwise, so we lay it along here, and this would be the same length of the radius, just laid on the arc. The angle that's formed there, this angle is 1 radian. So when the angle goes up to the circle and has the arc length being the same as the radius, that's 1 radian. And if we're looking at what it is in terms of what we're familiar with, 1 radian is about 57 degrees, if we were to look at it in degree measure. So let's go ahead and define it in terms of what the words are that go with it. 1 radian is an angle in standard position so it could be other places on it as well, but usually we start with our initial side as the positive x-axis, and we go ahead and we rotate counterclockwise. So an angle in standard position where the arc length equals the length of the radius. That's what we showed here, is that we've got that arc length equal to the length of the radius. So a radian measure, how you calculate it, it has to do with comparing the arc length of a circle and the radius. So we're going to start doing trig in circles now, where we start making those comparisons. So if you take arc length and divide it by the radius, you'll get the radian measure. So this is an important kind of definition to know. That's how you figure it out. And that if you look at this, for instance, a full arc length all the way around is called a circumference. So if we took the circumference, 2 pi r, and divided by r, the radius, you get just 2 pi. So if we're looking at a full circle, in degrees all the way around was 360 degrees. Or in radians, if we take 2 pi r, which is all the way around, and divide by r, you get just 2 pi radians. Or you could just put 2 pi for that. For a half circle then, halfway over is 180 degrees. Or in radians, that's going to be half of this, it's going to be pi radians. So pi is going to be very significant in the measurement of radian measure angles. Let's go ahead and look now at what we have for the different spots on the axis. If we've got an XY axis, so this is X and this is Y, these are called quadrantal angles. Because quadrantal angles are angles that end on an axis. So if you start here at 0 degrees, the initial side, and you go here, okay, that's a 90-degree angle if we do it in degrees. If we do it in radians, that's going to be pi over 2. So I'll list it on both sides just so you know what those measures are. If we keep coming and we go all the way over to here, this angle to the other side of the x-axis, that will be 180 degrees or pi radians. And if we keep going to the y-axis here, that's going to be 270 degrees or 3 pi over 2 radians. And then if we keep and follow up and finish here, this would be either, I'm going to put 0 degrees or 360 degrees, so it's either one of those two. If we were to do it in radians, it's going to be either 0 radians or 2 pi radians if we go all the way around for it. All right, so this would be our quadrantal angles, how we'd list them. And so you have to start getting familiar that if I say pi over 2 radians and you're familiar with degrees, think of that as 90 degrees. Start getting familiar with how those two work together. Now, other angles besides these quadrantal ones also can be converted and related to one another. So what we want to know is how you convert from degrees to radians and how you convert from radians to degrees. So if I'm given an angle in degrees, to convert it to radians, you take the degree measure and you're going to multiply it by pi over 180. This is our conversion factor. The 180 degrees will cancel out the degree part of it, and then it will end up in radians because we'll have the pi part of it. Notice that's what happens at this part of of our quadrantal angles. Same thing with radians to degrees. If we have it in radians and you want to convert it to degrees, you multiply by, now we're going to get rid of the radians, so the pi part of it will be in the denominator, and then we'll multiply it by 180 degrees to have it convert into degrees. So these two conversion factors will help us to do problems like this. We're going to convert from 225 into, this is degrees, we're going to convert it into radians. So you take 225 degrees times, and you multiply by pi over 180. Notice that the degrees and this cancel, so you're going to have 225 degrees. The measurement unit of degrees will cancel out. Now we've got to reduce that down. So if you reduce this down, you can take out several numbers if you reduce it, and it reduces down to, let's see, if I take out a 5, I'm going to end up with 45 pi over 36. Okay, and I can reduce further. Both of these have a 3 in it, so I can take out a 3, and actually they both have a 9 in it. So we can convert further, and I'll make this 5 pi over, excuse me, if I take out a 9, that's going to be, I'm going to have, if I take out a 9, I'm going to have a 5 pi, and then take out a 9 here, I'm left with a 4. So 5 pi over 4 radians when I reduce that down. Now this one, we're going to convert it into degrees. So this, it doesn't have a degree marking, so we'll say it's in radians. We'll multiply by 180 over pi. Notice that the pi's will reduce, leaves you with 180 degrees over 3. That will give me just 60 degrees when I reduce that one down. And then lastly, 270, we're going to show one of the quadrantals. So if I take 270 degrees times this conversion factor, pi over 180. So notice that I'm going to make this then 270 pi over 180. The degree factor, the degree units will cancel. You can cancel out a 10 out of each, so you have 27 pi over 18. Then you can, again, you've got a 9 that you can reduce out. So this is going to be 3 pi over 2 for the radian measure. So we've introduced the new idea of radians. This was a way to measure angles, to give them angle measures. And what we'll do is we'll use these conversion factors to understand the relationship between degrees and radians, get more familiar with them, but we also need to just have an intuitive sense of what happens on the quadrants with these, get to know these values so that you know about which quadrant we're in as well, and then understand that the definition of a radian is where you take the arc length, divide by the radius, and you get the radian measure of any angle that's in a standard position on a circle.